Before we do the outputs, we need to address this problem of the seeds. We need to come up with a way of generating however many seeds we need from one seed. We need to calculate how many seeds we need in our tool and provide one master seed that changes them all to different numbers. The reason for that is you don't want to give an artist, unless it's a very specific thing that you're targeting, you don't want to give an artist 17 seeds to change to get a different look. You really want to just change your entire look based on one thing. So the first thing I'm going to do is go through here with you and count up how many times we need a seed. 1, 2, 3, 4, 5, and there's a hidden one here as well in your instance creation. 6. So we need 6 seeds. And this is where me talking about downloading other packs helps. So I'm going to use a compound from my pack, from the Valhalla pack, that I built to generate seeds. And what it's called is prime sequence. The way that works is it makes a sequence of prime numbers that starts at this number and is this many things long. And it does it with math, more or less. Okay, it's basically this compound here will check to see if it's prime. If not, it'll go on to the next one. Go in and investigate it if you like. This is how we're going to make our master seed. And what we're going to do is use our master seed as our start value. Okay, because this makes a sequence of prime numbers that is this many numbers long, starting at this number. Whenever you change the start number, the seeds will change. And that's exactly what we want. We need 6 seeds. Oh, and it spits out the array of those seeds. Okay, we need 6 of them. I'm going to make 10. Why? Because you might want to come back and add things to the tool, whatever you need. So I'm now going to plug in the start value into its own input. I'm going to call this seed input. And I'm going to call this seed. And this has already turned up in Maya. There it is. Okay, doesn't do anything yet, but it has turned up. Everything is still connected, which is awesome. So I have a prime number sequence that starts at whatever number we put in. Let's put in a number. Let's go over to Maya. Here, let's put in, say, 4,812. That's our seed, just to test and to check. All we need to do now is get seeds from this array to plug into what we need. So if I just pop in a get from array, with index 0, and I can plug that into here. And because this is all working, I can check to see what number it spat out. So it turns out 4,813 is a prime. Then I can get the next one for the next seed, which is, I believe, this guy here. So we can just pull the array out. I'll put this down a bit. We'll pull the array out a bit. Get from array, index 1, plug that in to here, and we'll check to see what this is. 4,817, 4,812. Perfect. Let's just pull that watch point off so we can see what we're doing. Now if I go back to Maya, here, remember those numbers, and we'll change this to 348. Our seeds have changed, 349, 353. They're different seeds. They change every time you change the start value. So that's just the way I came up with to, basically get seeds from a master seed. Now, it's reasonably clumsy because it's, you still have to work with getting from an array. There are many other ways to do it. You can take a random number and add a number to it, make that your seed. You can take a random number, do a bitwise XOR on it, and make that your seed as well. You can do it all kinds of ways. This is just the way that I've chosen to do it. So if you want to find your own way, go for it. But now we've got 2 seeds. We'll do another get from array. We'll make sure that that's set to 2 because it's the 3rd one we've done. And then this guy can go off and be plugged into Selections, randomization, seed. That's our instances seed taken care of. That's great. I'm going to pull out from here, come down here to where we need more seeds, put another pass in. And it's just rinse and repeat from here. Just making sure that I change that to a different number every time and plug it into the seed value that I need. So I will speed up the rest of this. That is now going to give me a different seed for all 6. If you wanted to tidy that up, you can just use these pass nodes to run what I like to call a bus, so that you're just pulling things off the bus when you need them, leaving them on there when you don't. It just makes for a tidy, little bit of a tidy way to do things, but yeah, that's up to you. It's reasonably tidy anyway. A little bit untidy, but these things are. So now we have the ability to change all of our randoms in here with a seed, with a single seed. So let's add some random. So let's rotate those a little bit. Z, we'll add some random to it, like that, and we'll do it in the Y as well. Just a bit of rotation and another rotation there. That's got some nice randoms going on. And if I just change this master seed, you can see that it's happily changing all of the randoms in the tool at once without having to go through and change 6 different seed values. Okay, so that's how that works. Set that back to 0. We'll get our defaults back, so we'll set all of those to 0. Cool. Moving on, the next thing we need to do, and it's the last thing we need to do, is our output, right? So now we have to think about outputting this, and we have to think about this. When you think about the output of your tool, you need to think about not only can I get it back to Maya, but also where is it going from there? So for you guys, this is an environment layout tool for a game engine, where you might be laying out an environment in Maya and you want to put in miles and miles and miles and miles of power lines or fences or washing lines or Christmas lights or anything that's cables on points, basically. You know, submarine cables, whatever. You want to do all of that. You need to think about, where is that going? Is it going to Unreal? Is it going to inform an Unreal? So do you just need to take the point data out? You know, do you need a USD point instance to go to Unreal? In this case, we do. Do you want to render it in Maya? Are you working in a cinematics department, which may or may not render with the engine? Are you working at a movie studio, VFX studio, where you need this to go out as an asset with its UVs and all of that kind of thing? What we're going to do is try and build for both scenarios. We're going to build the ability to output through Maya, which means we can render it. So we can render it in Arnold. We can set that up in Bifrost or set that up in Maya. Also gives us the ability, if it's just a Maya object, if it's back to being a set of meshes, an array of meshes in Maya, it also gives us the ability to output to a game engine as an FBX, because that's what Maya does now. We're also going to build a USD output system, so we can just drop it straight into the Unreal Engine and we're off and running. Now, when you're making a tool, what you need to think about is how you're going to get that out. Right now, this has no output. This is a terminal. This is just showing us what's going on. This is just something I put together to build it with. We need to be able to get this back out to Maya. And we also need to think about what we're going to use it for. And in our case, it's going into a game engine. In other cases, it might just be going into Arnold for rendering. Or people may want to just receive the rendered version as well. So what we're going to do is set up 2 different outputs. We're going to set up an output to Maya. So we're basically just going to convert what Bifrost makes into meshes and put that out to Maya so that the artist can do whatever they want with it. FBX export to a game engine, adding UVs, painting textures, whatever they want. It's an output to a Maya object, which can then be exported as an FBX, an OBJ, a Maya.ma file, whatever you like. The other one we're going to provide for our artists is a USD output. And that's for you, game TAs. That's for you trying to get Bifrost into Unreal through USD, or it's even for anybody in the film industry who wants a USD stage to come out of this. We're going to output a USD stage for it. Okay, so let's handle the easiest one first, and the easiest one of all is to get it out into Bifrost. And here's how we do it. Make an output. Sorry, this is the one that gets it out into Maya. I'm going to leave this terminal here so we can switch it on and off as per and just see what's going on. I'm going to put a pass on this noodle. What is this noodle? This noodle is the instances. So we'll output that. Okay, now here's the problem. Until those instances are baked, they are just points. Okay, if I output this to Maya right now, it's going to be points. That's it. It's going to be these points here. Might be a good thing. Might want to output that as instance points. Output the object itself. The more you can give people to use, the better it is. I'm going to leave that there, but I also need to output the meshes. And the meshes is what's going to be really important. So I need to bake the instances. Bake instance geometry. Okay, and we will just put merged meshes out. And we will say baked instances. Now we've called these instances all the way through the tool. There's no reason to stop now. The output is much more likely to be used by a TA or in VFX a TD who's preparing things along the pipeline. But that's also why we put out the points. The artists probably won't use the points unless they're going to instance something after the fact. But I can almost guarantee that the technical people, the pipeline people, TDs, TAs, they will. They will use them for something, or they will be annoyed that it's not there, come into your Bifrost tool and make it go out themselves, which is cool. Now we need to get the problem child to come out. And the problem child is the curves, okay? The strands. What the strands are right now are, if I was to say, do a get from array, this is our strand array here. If I was to get a strand array and just get from the first one from that array and put it out, that's it there. That's what that strand is. That's how we're able to control things per wire and per pole, because each of these is a single unit. Couple of things we can do here. One thing we have to do here. So the first thing we can do here is just merge strands. Now, if I drop that into the output, that's everything. That's all of that is a single strand object. That's the way we're going to go, I think. But let's see. Let's work through it and find out. So we're merging the strands. That gives us a strand object. And if I use the first of the output compounds I asked you to download and install is one from me called strand to mesh. There it is. This is just installed with the VHH pack. I gave you the address at the beginning of the video. There's also links in the folder. What this does is it extrudes a strand, and it not me that does the extrusion. This is built around Maxim's extrude strands. Okay, so I'm going to be straight up. That is really just a wrapper for that. Maxim did all the hard work. I just piggybacked on it. Maxim is awesome. Download his stuff. So I used Maxim's stuff to make the tube extrusion. I used Aslan's stuff to make the ribbon extrusion. And then I just wrapped it up and published it. Now, really the only reason I published it is so that anybody watching this video, you, for example, will know where to get it. And it's all wrapped up into one thing. So if I plug in our merged strands to the incoming strand and then output that to the value, and you can see what it's done. Sorry, it's used Maxim's extrude strands to make wires for us. You can see that they might be merged, but they're not a single unit. So now you can start adjusting. You can make these very much thinner, like so. And when you do that, you avoid all of that horrible fact that they're actually just single objects. These guys are not quite Maya meshes yet, but they are meshes now. You can make them even skinnier. So you've got whatever it is you want. These are just artistic decisions. And as such, they're going to need to get a control. Okay, so that people can control them from outside of the tool. We know how to do that now. The other thing that this does is it takes into account attributes that are on there already. So if there's a point size on these, this is not so important for the tool, but it is important for you building it. If the strand you're setting up has a point size on it, this will respect the point size. It will override this. But for that, that's fine. You can control the shape of the extrusion, right? So right now that's a square extrusion. You can see there's 1, 2, 3, and behind there 4. And if I take that up to 8, it's going to become more of an octagon. So that just allows you to change your resolution on output. Okay, speaking of resolution, we forgot to set up a control here. So this is more of a look control, so I'm going to put that into that one and call it wire resolution. Why did everything disappear? Same as before. Because I forgot to put that in, and I've put it in now, you can see it's at the bottom. If I want that up at the top, I'm going to have to delete all of those and start again. So what I'm going to do is I'm going to delete the seed. Go into the seed control, which is here. And I'm simply going to delete that input and make a new one. Put our start in there, rename it to seed. And if I've done everything right, lo and behold, I come back and that's now at the bottom. So it's flipped it down because I added it last on the second time around. Okay. Yes, I might have done that on purpose. Anyway, back to output. So now this is going to need some settings. It's basically going to need the extrusion shape, because if I change that, if you wanted to, you could make that a ribbon, which, you know, would be okay in some cases. You see how it's now a flat plane. You can change the axis that it's extruded across, normal axis or binormal axis, or you can add a custom axis, and the thickness and stuff still works. But I'm going to prefer a tube. So you can give the artist the opportunity to use a tube or a ribbon for this because of me putting all this together and stuff. Either way, we've still got a Maya output here. And you can look at the node editor and see it. On the output side of things, there's the instance points output. That corresponds to that guy. There's the baked instances output. Corresponds to that guy. And this one is still called value, which I think is here. So we call this wires mesh. And that's now changed. So those are your outputs. Those can be hooked up to whatever it goes forward to be hooked up to, or added to a shading group, or whatever it is you want to do with it. But this is essentially the Maya output. There is one more thing we can do to make this even better and ready to be exported. Right now, you're still seeing nothing in your outliner. You can see your Bifrost, that's working, that's all that guy. But nothing else in the outliner. The last thing we want to do is take this guy, create a Maya mesh, create this guy, create a Maya mesh. Now we can hide our Bifrost, and we actually have mesh representations of the Bifrost and still connected to the tool in Maya. By still connected to the tool, what I mean is if I come to the layer editor, if I come to the channel box and select this and say I only want 2 of those wires, it's procedural. It will go through and output what you're telling it to output. It remains connected to Maya. And you can see that in the graph in the node editor here. You've now got these 2 outputs, Bifrost Geo to Maya, and then wires mesh shape, baked instances shape, which both have, just select that guy, and they both have transforms, and that becomes your output. That's the easiest way to do it. From here, you can take these and export them to whatever you like, FBX, OBJ, PDF if you're really feeling weird. You can do all of that kind of stuff. And that's exactly what we want. So it's at this point here, we've actually got an output. You might want to say tidy those up a little bit out after the fact and just say Maya mesh output. Like, the tool's not going to care where it lives because it knows what shapes it's connected to, yeah? So if I come to the channel box again, select the right thing, take our wire count back up to 4, maybe 4, not 7. Yeah, it's in a group, but it's still happily procedural. This makes me very happy, should make you very happy too. That's our output. That's the easiest one. Okay, so that's outputting to a mesh. We've also got the instance points coming out, but that's not in this group. That's not a mesh output. We haven't made a Bifrost to Geo here because those instance points are more of a pipeline bit of data that we might want to send around, that we might want to plug into Arnold. We might want to plug into something else, some proprietary tool we don't know exists yet. But that's why we're not outputting them there. So this is the Maya output. These are the Bifrost objects. We're done here for that. Now we have to output in USD. So now that we've got the mesh output working well, and it is working well, we can go on to the USD. But before we do, I just want to really quickly show you rendering this in Arnold. You can do it inside of Bifrost or you can do it outside of Bifrost with the Maya mesh output. I'm going to do it inside of Bifrost because Arnold pretty much reads Bifrost stuff pretty well. So here's how we're going to do it. I'm going to take the wires mesh, assign a material to it, and it's going to be standard surface material. Goes in there, and then we're just going to make that go black with quite a high specular. Okay, so, and then that just replaces the output. So let's turn on Arnold and see what happens. We're going to get a very black screen because we have no lights. I tell a lie. We have whatever is shining on there. So let's have a look at it and we'll create really quickly a physical skylight. Looks like that, and now we can see our wires. It's not just a black background anymore. And Arnold is rendering happily. The reason I show you this is because that's literally all you have to do to get it to render in Bifrost. I can still go to my controls in my channel box here, select my Bifrost, and let's say do something really quite visible. We'll take some wires away. It's working well. That's fine. So what I'm trying to show you is that this is procedural all the way through. It's procedural all the way through to Arnold. If I want to say up the wire resolution just a little bit more, so we got 24, you can see it's subtle. It's got just a little bit smoother there. Why don't we take that down so it's not smooth? You can see the chunkiness turning up there real quick. And then back to, whoops, that was a bit too much, but it still worked. Back to 24. You can put a texture on the mesh, you can do all kinds of stuff with it. That was just a really quick side step into Arnold, so we're going to turn that off now and go back to Bifrost. We might get rid of the dome light as well. There we go. Okay, so our next challenge is getting it out to USD. And let me just get rid of the Arnold shader for a second. There we go. Probably need to plug that in. So we're back to where we were. So we've made our first output, and this is our Bifrost output. You can, if you want to, make these two in an array and output them, but it will still output separate objects into Maya. So that's not too much of a problem. Let's get on to doing the USD. So we have a bunch of tools that we've already developed throughout this course for USD. The first one we're going to need is getting out a point instancer, because these poles are nothing but an instance. And of course, the benefit of using USD for this is we can skip this step, the bake instance geometry step. We can skip that entirely. So I'm just going to go and fetch a compound we made in the last lesson, and here it is. So this is part of the USD output I was showing you in the last lesson. This is the point instancer output. And what this is going to do for me is, we'll have a quick look in here. So string check, just so you know, checks to see if there is a slash at the front of the string. If it doesn't, it adds one to it. That's what string check is doing. Then we didn't need tree prep in there. That's left over. Mesh preparation, the instance array goes in. We add the number of our loop to a string as a string to our name. So it gets unique names and then defines the mesh as we do. We know about that one. And these are just the inputs, which is what you see here. So this is what this is designed to do. If we take a look, you see there's no stage in here. It's not adding to a stage or anything. This is designed to make a point instance of definition that we can add to our end stage. So let's try that out now. I'm going to hide the Bifrost for this so it just looks like nothing is there. So we have our instance points up here. Let's put a pass node in. Plug that into our instance points because that's what's going to generate our points. And then we have what we don't need the baked instances. What we need is the instances that go in to the system, which are these guys here. So we're going to take that array out and we're going to pop that in there. Then I'm going to very quickly create a USD stage. Just for our testing, so there's a USD stage. I'm going to do an add to stage. This will become our USD output, and we'll put the stage in there. I'm just going to output that there so that Maya sorts itself out and picks things up. It'll take a second. There's the USD proxy turning up. It's got nothing in it right now. And we'll just add the point instances to that stage. And there you can see our polls. Now is a really good time to check to see if all of the settings we're putting into our polls are still working. They should be, because they should be carried by these points, but it's always good to test. So let's go into the channel box again. Let's select our Bifrost, even though it's hidden, that's where our controls are. This is just our output. These are the controls. We'll zoom in on this guy, and the easiest thing to do possibly is just to check if he still rotates, and he does. That looks like it's working beautifully. We don't have any wires yet for obvious reasons, but that looks like it's working really well. We can try to do other things like rotation random along the X. That's pretty nice. That works. Yeah, everything's hooked up, everything's connected, and more importantly, it's flowing through to the USD. Okay, because we've set up all of our controls in the procedural engine, that is Bifrost, we should be able to make a really, really simple USD output. So simple, in fact, I've got a strand to mesh, which is why I asked you to download the VHH pack and why I asked you to download the MJCG pack as well. This is the merged strands being converted to a mesh. This is what we see when, if I just hide the USD and show that, that's what these are. That is that output. So we should absolutely just be able to add that as a mesh to our MyUSD proxy. Define USD mesh. That should be all we need to do. What I'm going to do too is, of course, add a display color. Let's take our combined meshes that we made. We'll pop that in there. And let's add that to the stage. Let's hide the Maya mesh output. And there we go. There's our USD output. That's how easy it was. Now, that's not very friendly to somebody doing the output. For example, we haven't got anything hooked up here so they can control the length, the width of the strands on output or anything like that. But I have two things showing. Oh, I still have the Bifrost visible. It's just, you see the preview color's been deployed as well. So we can make that a black, which is great. So this is vertex color. That's just the. But for now, this is good enough for what we're doing. We're going to be working on that a little bit more later. But essentially, what this comes down to is this is our USD output. This is the absolute engine behind it. We can group all that into a compound and call it USD output. The point is here we have a tool with controls that change in the viewport for us, and that outputs in both a mesh way for Maya and a USD way for whatever else we want to use USD for. In our case, it might be game engines. In other cases, it might be for rendering and that kind of thing. Obviously, things like the resolution of the instances you put in and the UVs of the instances you put in, what you get out of them is dependent on what goes into them. The wires themselves, if I was to just swap those two around and look at our wires mesh here, look at our UVs, they have UVs built onto them. People can then change those UVs if they need to do stuff. But Maxime's amazing compound adds UVs to those on output for us. So that's one more thing taken care of. Also a really good example of why you should look around for other compounds you can use, because I just saved myself a bunch of time. So let's start cleaning this up so that we've got output options as well as input options. Right now, what we're looking at here are the input options. These are all the things that change the look of this and give us a different thing. What we kind of need now is to set up just a couple of output options. And really it's around strand to mesh. So we'll make a new input just like we've been doing. And we're just going to hook these up. So actually, I'm not going to do extrusion shape. I think we're building wires. It's a wire tool. They can stay as tube, which means we don't need to get any of this stuff out. Maybe just tube settings would be one. And we can just take these three as our most sort of common controls. Let's give them good naming, which basically just means putting wire at the front of them. Also, your tool requirements will change depending on what you're doing in the studio and what the studio does. Some studios might just want something to do this. Other studios might want something a lot more extensive that does this and fences, or this and roads, or like we did in week 3 where we put the street lights down the road. This is exactly the same sort of concept as that. Let's just put that in there and we'll just call this wire radial resolution. Okay, and there's nothing in the world that says you can't write an MD file for this either that explains all this stuff. So now this is setting up new tools is set everything, setting up new controls is set everything to 0, so we better go fix that. Our base width I think was 0.05. Yeah, now we have a bit of an error. So it really helps if you're setting your resolution of your extrude that it has a number in it. That's what I got wrong. So this guy was set to 0. Nothing was showing up. There we go. Now we have 8 sides on our tube. See, I make mistakes. Let's get all this hooked back up the way it was. All good. So now we have a USD output back. Great. Some other things that we need for our USD output is we should probably check the names of these. Mesh is not a good name to have. Right, so in here where we've got our define mesh, define USD mesh, let's give that a proper name. Let's call that poles. And I've already renamed the instancer. Oh, that's not poles, is it? No, those are wires. Let's call that wires. I've already renamed the pole instancer. And once we've hooked up the instancer seed, everything should be done. So what we end up with, let's just turn off the terminal for now, because in fact we'll delete it, we don't need it anymore. What we end up with is a working studio ready tool. You might want to do some interface things to it, but it's still ready to use. You'd also want to change some names in the USD, but like that would be based on your studio pipeline and how the pipeline used the USD as well. So they might demand specific names for this. I probably should name that properly. So let's just get rid of that. And then inside of here, where we've got mesh prep, it's looking for the mesh name. Sorry, not in, that's the point instances. Inside of the mesh here, we should probably call this wires. There you go, it's changed there. So I'm not making things like, I'm not outputting the names. I'm not pushing the names out to Maya so you can change the names or anything like that, because that does tend to be studio specific. But with that, we now have, if I just, let's close our outliner and a USD layer editor for now. I have something that I can bring in to Maya. I can import this as a tool, or I can load it through script, or whatever it is I want to do. We don't need Bifrost anymore. Don't forget we're looking at the USD here as well. So I'll need the outliner for a second, just so I can select that. And now we can go ahead and make all the changes we want. So let's get this up to 15 or so, but let's knock out a bunch. So 0.2, 0.7. Going to make quite a lot of knockouts. Don't really like that, so I'm going to go ahead and change the seed a bit. So I've just got a bit more of a sort of a layout that I'm more fond of. Or, I can probably take that down to 0.4 instead. And again, change the seed. Cool. Something like that. Maybe there's a river going across there that you need to set up or something. I can change the wire sag more or less, quite a lot less in fact. Something like that. Pull the minimum, pull the minimum down a bit more and the maximum down quite a lot. So you've got quite droopy sort of wires going on. I can make whatever look I want given the attributes that I've hooked up. And of course I can change whatever curve I've got an instance on. I can draw a new curve on my terrain. I can do all kinds of stuff and everything's just working. Well, sorry, that's how you take an existing Bifrost compound setup and turn it into a tool that anybody can use. So this one would be aimed at environment artists or layout artists, anybody who needs to set up something like this. So if I select that guy and get his verts, and I can then also, I've still got all the control that Maya gives me coupled with the control that Bifrost gives me. And I mean, there's nothing to stop these guys going up a hill, right? For example. So yeah, that's it. That's how you take your Bifrost compound and make it directly relevant back into Maya as a tool system. This was a simple example. There's going to be some stuff that, I literally can't tell you about, like different studios, pipelines, demanding different types of data, demanding different naming conventions. All of that you'll learn when you get to the studio. Other than that, hey, I'm done with you. Thank you very much for taking the Bifrost workshop. I really hope this has helped you in your Bifrost journey. There are so many resources out there. If you get stuck, you can find me on the Discord pretty much during daylight hours, Eastern Standard Time. But I'm not the only one there. There's many people there. It's a really good community. I would encourage you to join it. Autodesk has its help pages. It has its own forums. Whether you're a student just starting off or whether you're the CG supervisor of a major animation company, we don't care. We'll help you with whatever problems you've got. And if we don't know who to ask, we can find someone that will know. Point of the matter is, thank you so much for attending. Thank you so much for listening to me for these many hours. And go forth and Bifrost. I hope you have a great time. Thank you so much.